Our newly armed hero is going to need some enemies to fight. Let's place some orcs across the top of the screen for him to hurl those shiny new axes at. We create orc.rb within the game objects directory and set the orc class up to inherit from Gemini game object. And much like the dwarf, the orc is going to have the animated image behavior. Within the load method, we specify that it should animate as an orc, which will cause it to load several ping files prefixed with orc underscore from the data directory. And now let's create instances of our new class. Within the load method for the play state, we're going to create 4 orcs to go across the top of the screen. We call the state's create method and pass it the symbol orc, which will tell it to access orc.rb within the game objects directory and load the orc class from it. We then position that instance across the top of the screen in 4 different horizontal positions. And here are our orcs. They seem pretty indifferent to our hero's attacks, though. Those axes just pass right through the enemies, and the way to fix this is to make them tangible. So we're going to start by creating a tangible manager within the play states load method. We create an instance of the tangible manager class and then set it as the tangible manager for the play state. We then tell the orc that it should have the tangible behavior. Tangible objects have an area called their tangible shape. Inside this area, it counts as a collision. Outside, it doesn't. So we're going to set the orc's tangible shape to a box 48 wide by 48 high. Then we need to specify what should happen when there is a collision. So we call the onTangible collision method, and we're going to send it to the handle collision method, which we'll define in a moment. The handler is going to receive an event object, which is, among other things, going to contain info about the 2 objects that collided. A reference to the other object collided with is stored in the other tangible attribute of the event. So first we test to see if this orc has collided with another orc, and we'll ignore the event if so. If we didn't do this, orcs would kill each other when they ran into each other, and we don't want that. So, having confirmed that this is an object we actually do want to collide with, we tell the GameState's sound manager to play the sound orc death. Orcdeath.wave in the data directory just contains a grunting noise that the orcs will make when they die. But when we play the game, it looks like that collision still isn't actually happening. The reason is that although the orc is tangible, the axe is not. So let's go fix that now. We specify that the axe should have the tangible behavior. And then we also need to set its tangible shape. We'll set that to a box whose size is equal to the axe's image's width and height. That way, even if we change the image later, the tangible box will change shape with it. And then, as with the orcs, we need to specify what will happen when there's a collision. We call onTangible collision, and this time we're going to pass it a block instead of a handler method. Just like a handler method, a handler block receives an event object. And just like with the Orc's Death Grunt, we're going to tell the state's sound manager to play the slice sound. That'll be the sound the axe makes when it hits its target. Also tell the game state to remove self, that is, the axe object. That'll cause the axe to disappear. There's our collision. You can hear the axe making the slice sound and the orc making the orc death sound, and also the axe disappears. Let's add some code to our orc's collision handler. Whoa, fast typing. Anyway, let's have the orcs disappear and be replaced by a fading skull when they die. So we're going to reset the orc's image to the death image. And then to handle the fade out, we'll add a 1 second long countdown to the object. And we're going to have it update 30 times over the course of that second. And with each update of this countdown timer, we're going to make the skull a little bit more transparent. We're going to set the alpha or opacity value of the object's color to lower and lower values, the closer to complete the timer is. And when the countdown is complete, that is when the skull is fully faded out, we're going to ask the game state to remove the orc object, making it disappear. And these timer methods are all provided by the timeable behavior, which we'll add to the orc object. So now when there's a collision, we change the orc's image and cause it to fade out over time until it disappears. And you can tell the orcs are truly gone because there's nothing left for the axes to collide with, except for each other. Let's modify the axes so that they don't collide with each other. Within the axe's collision handler, we look at the other object that we collided with, and if it's another axe, we're going to ignore the collision. And we're doing this by seeing if the other object has the tag axe applied to it. Of course, there's not much point testing for the axe tag unless the objects actually have the axe tag. The ability to add and test for tags is provided by the taggable behavior. And we ensure that axes are appropriately tagged by calling the add tag method when they load. We use tags on the orcs as well. We assign them the taggable behavior. And we could conceivably add other enemy types later, so we're going to give them the more generic tag enemy. So as you can see now, even when the axes overlap, the collision event is ignored. Well, at this point this is an awfully easy game, so let's give the orcs a means to fight back by throwing rocks. We add an attack method on the orc object, and we're going to instantiate a rock. We don't have the class yet for that, but we'll create it momentarily. As with the dwarf's axes, we set the rock's position equal to that of the orc that threw it. And we tell the rock to move at an angle of 180 degrees, that is straight downwards, at a speed of 0.5. We'll also have the orc perform the throwing animation, so it looks like he's throwing the rock. Finally, we tell the game state's sound manager to play a sound as the rock is thrown. So, orcs have the ability to throw rocks now, but they're not actually using it. The orcs need something to coordinate their attacks, and we'll do that through our own custom manager. If you create a manager subdirectory, you can store your own manager classes within it. We'll call our new class an enemy manager. Within enemymanager.rb, we'll create the enemy manager class, and it's going to be just another game object. Game states know that managers exist and that they're assigned to manage certain things, but aside from that, they don't differ from game objects in any other way. We'll give our manager the updates behavior so that it gets events when the game state is updated. And for now, we'll specify that when there's an update, we should call the attack method of the enemy manager. Update handlers receive a delta value, the amount of time since the last update. And what we'll do here is choose one of the enemies under our control at random and tell it to attack for us. Not every object on the playfield is an enemy, though. The game state's game object manager has a list of all the active game objects. If you recall earlier, we gave the orc the taggable behavior, which gives it the has tag method, and then we assigned it the enemy tag. So if an object has the tag enemy, we'll consider it to be one of the enemies under our control. All we've done at this point, though, is create the enemy manager class. The state isn't actually using it to manage enemies yet. So within our playStates load method, we set the enemy manager to a new instance of the enemy manager class. One more detail to take care of before we begin our coordinated attack. We need rocks to throw. Rocks are very similar to axes, so I'm going to spare you the details of their implementation. We start back up, and the game seems to be running very slowly for some reason. And it's probably because the enemies are attacking constantly. Set the enemy manager up to only attack after a certain amount of time has elapsed. This is where the delta value passed to the update handler comes in handy. We'll accumulate them and store them as the total time since the last attack. And we'll skip attacking if not enough time has elapsed since the last attack. And what constitutes enough time? Well, it's going to be stored in this attack delay variable. And we'll set the attack delay via the predict next attack method. We'll wait a minimum of 1000 milliseconds, that's 1 second between attacks. And then in addition to that, we'll have a random delay of up to 3 seconds more. When it is time to attack, we'll reset our timer. And call predict next attack to set the delay before another attack. We also have a little housekeeping to do in the load method to set the initial attack. So now, starting the game, you can see that the attacks are a bit more spaced out, but our poor orcs, bless their hearts, are simply hitting themselves in their heads with their own rocks. We've already told rocks to ignore collisions with other rocks. In similar fashion, we'll tell them to ignore collisions with the enemies that throw them. And there go our projectiles safely on their way. This is still too easy. Let's give our player moving targets. We start by setting up a walk speed for our orcs, and we're going to give them move left and move right methods similar to what the dwarf has. Within each method, we'll check if we're already dead and skip moving if so. We change our X position to the left or right as appropriate, and we're also going to do the walk animation. The enemy manager is going to be responsible for having the orcs move in a coordinated fashion. First, we set a duration of time that they should walk in one direction for, so they don't go forever one way. And just as the attack method is registered as an update handler, we'll register the move method as well. And as we track the time since our last attack, we're also going to track the time we've been walking in one direction. We then call reset move direction, which will change from calling the move right method on all the enemies to move left, or vice versa. And there you have it, moving, shooting enemies. Obviously this little demo can be taken quite a bit further, but we've shown you all the basics of Gemini. With what you've learned today, plus the helpful documentation and forums on Gemini.org, you should be ready to start your own game.